you guys that are you guys ready for your learning or not. If you guys are ready for learning, type down in the comment box you are ready, and let's get started. Come on, type down in the comment box that you are ready so that I can go ahead and I can explain you what exactly I brought for you guys and what exactly we are going to discuss today. So type down in the comment box if you are ready for learning. Type down now. I want your approval and I want your energy to get it back to you only from my end. Okay, great. Great. Let's start the session. So let's talk about algorithm. Algorithm is nothing but a step-by-step solution for those algorithmic problems, for those computation problems which we have in our computer world. So what does it mean by step-by-step solution? Step-by-step solution is nothing but a structured solution which we can write in a general language, general English or Hindi or whatever your language is in that, so that we can understand if we will perform this, then this, then this, then this, then this, operation will be done, problem will be solved. That is the algorithm. There are certain way or there are certain characteristics the algorithm should have, like it should stop, it should have finite number of statements and something it should have minimum one input, it should have some output and something. We are not going to discuss that. We will be discussing that in algorithm chapter, algorithm subject separately. Let's talk about more things which are required for our data structure. देखिए हम जो है बहुत स्पेसिफिक रहेंगे. We will be very specific. जो हमें जरूरत है वो रखेंगे, नहीं रहेगा नहीं लेंगे. Whatever we require, those we will keep. Nothing required, don't require anything, we will not take it. Chal, let's start the session. So algorithm is this, but why we need the analysis? Why we need the analysis? Just because we are Indian and we Indian are good in analyzing everything. देखा उसको, उसने ऐसा पैंट पहना, देखा उसको ज्यादा मोटा हो गया, देखा उसको इतना भी नहीं कमा रहा है, देखा उसको इंजीनियर बन गया, देखा उसको ये कर लिया, देखा उसको वो कर लिया. Analysis is there in our gene, but this analysis is not रिलेटेड टू अपने नेबर को एनालाइज करना या अपने बेस्ट फ्रेंड को या किसी फ्रेंड को कमेंट करना. दिस एनालिसिस इज वेरी डिफरेंट. व्हाई वी एग्जैक्टली एनालाइज द एल्गोरिथम? Now see, the thing is, to solve one problem we may have multiple algorithms. To solve one problem we may have multiple algorithms. Among those, which one is better, in what term, how do you compare them? How do you compare two or more algorithms which are trying to solve the single problem? And that is where the analysis of algorithm comes into the picture. अगर हमें दो algorithms को compare करना है जो एक ही problem को solve करती हैं, तो हमें लगेगा analysis of algorithm. Don't worry guys, if you don't understand Hindi, I am just repeating whatever I have spoken in English. So what I am saying is, analysis of algorithm is required when we need to compare multiple solutions for a problem. So if you have written multiple algorithms for the single problem and you want to compare that which one is better in what term, then you need to analyze the algorithm. And this is the way to go ahead with analysis of algorithm. Now listen, if I ask you a simple question, if suppose you have studied the sorting algorithms, and I am asking you a simple question that which sorting algorithm is best? Which sorting algorithm is best? Now see, you can name a few this one is best or that one is best, but I will not recommend you to give that answer anywhere, even though in interviews also आप ये आंसर नहीं दे सकते. Why? You need to ask me a cross question, sir, that sir, what is the basis through which you need to know, on which basis, on what basis you want to know that which particular algorithm is better. Now let me ask you a simple question. The question is, which car is best? Which car is best? Everybody will have different answer, but you should ask me a cross question, sir. What are your requirements? You want an SUV or MPV or a hatchback car or a long car or small car, or what? How many seater car you want? What is your budget? What should be the maintenance cost? You want to have the look better or more features or less service cost? What are the requirements of yours? And that is where I will recommend you always to answer each and every question of the analysis. If somebody asks you, what is the analysis? What is the analysis of algorithm, or which particular algorithm is best? You need to ask me a cross question, sir. What is the basis of comparison? What is the basis of analysis? So we have basically two bases of analysis. One is space, another one is runtime. The algorithm needs how much space to run, and algorithm needs how much time to run. And I guess all of you are aware at least to know these words, right? All of you are aware of these two words? All of you are aware of these two words? Yes or no? Of course you should be. If you have taken these courses in your engineering, I'm not asking you have learned these courses. I am just asking if you have taken these courses in your engineering, you might have heard these words. मैं नहीं पूछ रहा हूँ कि इसका मीनिंग क्या है. I am just asking, सुना है नाम at least? चलिए. So what is space complexity? Space complexity means space needed to run the algorithm. See, all of you who are saying yes, all of you who are typing yes, all of you who are not typing yes but at least speaking yes sir, हाँ हमको टाइप करने में दिक्कत होती है सर, but yes हम बोल रहे हैं. For those members I want to tell you one thing, that if you are learning live, this is the interactiveness which you miss in the regular sessions which you listen in the recorded mode. And this engagement makes you more efficient, more focused towards learning, and that is why we urge you to ask you to come again and again and again live. Okay, so what is the space complexity? Space complexity is space needed to run the algorithm. So this is exactly what is the extra space needed by the algorithm to run it. Does it include input size also? No. Input इसमें included नहीं रहता है. इसमें सिर्फ वो space included है जो algorithm को अलग से लगेगी. Input is already given to your algorithm. Now you need to write an algorithm in such a way that algorithm takes extra very less space, minimum space, and it can provide you the solution. That is the advantage of having this space complexity analysis. So space needed to run the algorithm, and I am writing here, it does not include except the input size. Input size is not included in this particular space complexity. Hope this is clear. Now next, yes, apart from the input, right? Yes, Sarthak, exactly. Now listen, what I'm saying, what is runtime complexity? Runtime complexity is time needed to run the algorithm. Now, see, nowadays space is not a big concern. Nowadays the space is not a big concern just because we have big enough memories and we have fast enough memories. The matter of concern here is this: any algorithm you should run or you should have minimum runtime complexity, which is major matter of concern now. So if you want to have a particular algorithm and you want to have runtime complexity calculated, how do you calculate runtime complexity? कैसे calculate करते हो runtime complexity को? To calculate runtime complexity, you have two options. You have two options. One is wall clock time, second one is number of operations. अब ये होता क्या है? होता क्या है? Look at this. If you want to calculate that how much time an algorithm takes to run, one option is you implement that algorithm in some programming language. After that, you run it on a particular system and check out that how much time it is taking, some nanoseconds or microseconds or millisecond or something. That is wall clock time. You measured it, fine. Now to solve the same problem, you implement that algorithm, second algorithm also, in some programming language. After that, you run it on a system and then get the time. So let's suppose you have algorithm number 1, which is taking t1 time, some unit, microsecond, nanosecond, something, for that algorithm, and A2 algorithm you have implemented on some programming language, run it on the system, and it is taking t2 time. Of course, you can compare that which one is taking less time. It is better, right? But this wall clock time is having a big problem. This faces lots of external issues. अब वो external issues है क्या? Somebody can tell me what are the external issues which affects this wall clock time ka comparison? Somebody, anybody? Now listen, what exactly the impacts? The first thing, which programming language you are choosing. If you are selecting two different programming language to implement A1 and A2, of course comparison cannot be a good one. Just because depends on programming language, number of instructions can be different, right? Now second thing, suppose you have implemented A1 very efficiently in some programming language. In the same programming language, you have implemented A2 but not very effectively. Extra statements you have written, extra looping you have written, multiple condition checks you have written. In that particular case, time can vary, right? Other than that, the time taken by these algorithms may be dependent on underlying CPU, dependent on underlying operating system. It might possible that when you are running A1 algorithm, and when A1 algorithm is being run on the CPU is running some more extra background jobs parallelly. You all know, right? The round robin scheduling. So suppose when you are running A1 algorithm, at that time 100 processes were there in main memory and they were running in round robin. When you were running A2, some 50 processes were only there or 60 processes were only there just because 40 background processes are done. In that case, you can't control these external factors. Of course you can't. At some time it might possible that your CPU will be so much of loaded because of background processes. At some time your CPU is not loaded. So you cannot control these external factor. In that particular case, we can say that wall clock time wala cheese will not work properly. This is not a good idea. This is not a good idea. So what happens? फिर क्या करें? फिर हम गए, साइंटिस्ट गए नंबर ऑफ ऑपरेशंस की तरफ. Then scientists went towards this number of operations. Do one thing. Let's not implement the algorithm in any programming language, but still we can analyze. Yes, we can do. कैसे? ऐसा जादू कैसे? बताते हैं. What you will do is when you run the algorithm, let's say manually, that first run this statement, then this statement, then this statement, this statement, then after that this. If any loop is there, then how many times the loop repeated and all. Based on that, you will calculate that how many number of operations or how many number of steps are performed to run the algorithm. You calculate those steps and based on that you give the answer. Based on that, you give the answer that this particular algorithm is taking these many steps, this algorithm is taking these many steps. Okay, this algorithm is taking more, this algorithm is taking less. Now, to define this number of steps, scientists have given a really great idea of using rate of growth. अब ये चीज क्या है, ये क्या बला है? दिस इज वेरी इंपॉर्टेंट पार्ट ऑफ योर सब्जेक्ट, जस्ट बिकॉज इफ यू अंडरस्टैंड दिस रेट ऑफ ग्रोथ, देन यू विल अंडरस्टैंड द टाइम कॉम्प्लेक्सिटी इन इट्स कैलकुलेशन क्वाइट नॉर्मली, इजीली एंड वेरी वेरी सिंपली. What exactly rate of growth is? Now look at this. Look at this. If I say, suppose I have given you an algorithm and an input of size 4. 4 inputs are there. You will have to run the algorithm. One algorithm you have run A1. And suppose in terms of number of operations, you have performed some S1 steps. And for algorithm 2, you have performed S2 steps for 4 operations. So number of operations can be here and there based on the number of inputs n equals to 4. Now suppose if I increase the number of inputs n equals to 8 or 10 or 12 or 15 or 500 or 200, of course these number of steps will vary. Yes. So now the accurate value of number of steps you cannot check out. The accurate value of number of steps you cannot compare. Why? Why you cannot compare? Just because it might possible. Just because it might possible that for a very small number of inputs, your algorithm will take almost same number of steps, but when you increase the number of inputs, the number of steps performed by two algorithms can be drastically changed or can be drastically increased. कैसे? एक सिंपल सी एग्जांपल बताता हूं. Suppose I have given you, okay, let me take one particular page. Suppose, assume I have given you n equals to 2 inputs in an algorithm. For algorithm, right? Now look at this. Suppose algorithm number 1 taken 2 steps and algorithm number 2 also taken 2 steps to perform the operation, its intended operation. Which one is better? Can't say. Can't say it. Let's say even in more different manner, let's say the algorithm number 2 is taking 3 steps. Now which one algorithm is taking better time or less time? This algorithm number 1 is taking less time. Let's say now, if suppose I have increased number of inputs n is equal to 10, this algorithm number 2 is still taking 3 steps only, and algorithm number 1 is now taking 20 steps, or let's say 10 steps. Now you tell me which algorithm is taking more time and less time. Now you are saying algorithm 1 is better. No, algorithm 2 is better this time. These class PDFs I will drop on our official Telegram channel, which is on the name, with the name Unacademy Computer Science, Unacademy GATE CS, sorry, Unacademy GATE CS. There is a Telegram channel, Unacademy GATE CS. Over there you will get all the PDF of this particular lecture and all the upcoming lectures on this channel. Now listen, I am telling you, when n equals to 2 inputs, you are having one algorithm taking 2 steps, second algorithm having 3 steps total. In that case, you told, sir, in this particular case, algorithm 1 seems to be the faster one. But when I have increased the number of inputs to 10, in that case, algorithm 1 is taking 10 steps, algorithm 2 still taking 3 steps. So in that particular case, how exactly you will give your output that, or your result of analysis that how many number of steps you are going to take if the number of inputs are equal to n. So in that particular case, we go for rate of growth. Rate of growth is nothing but a function which takes in input n and gives you the output. So rate of growth function is just a function. That particular function says if you provide the input n, the t is my function, my runtime complexity. T of n is nothing but runtime complexity, and this runtime complexity I will be giving in terms of rate of growth, and rate of growth is nothing but how the complexity increases when number of inputs n increases. With what rate exactly? With what rate exactly the runtime complexity or complexity increases? How means at what rate? I should say in more precise manner, at what rate the complexity increases when the number of inputs increases. Let me take a very simple example. Let's say when number of inputs is equal to 1, the number of steps taken is equal to 2. When the number of inputs is 2, it is 3. When the number of inputs is 3, it is 4. When the number of input is 4, it is 5. When the number of inputs is 100, it is 101. Can I write in this particular case t of n is equal to n plus 1? So I have written a function that time complexity, which is nothing but number of steps performed or number of operations performed, is equal to number of inputs plus 1 always. Now whatever the input you will give me, 1 input, then number of steps 2, 2 inputs, number of outputs or number of steps 3, if 4 inputs, number of steps 5, if 5 input, number of steps 6. This is called as rate of growth, and this particular rate of growth we are going to use to give the complexity. What is the advantage of using this rate of growth, a function, instead of just giving the concrete value? It can define the generalized value. कोई भी n की वैल्यू आप मुझे दो, any value of n you just give me, I will return you the appropriate value of number of steps in terms of this rate of growth. Just because I am not defining that these many concrete number of steps required, my number of steps are dependent on the number of inputs. Hence, I have given the output, I have given the complexity also in terms of n. So I have given a formula, I have given a function. That particular function is that function which gives me the number of steps performed by the algorithm when n number of inputs are provided. I hope सबको समझ में आई ये चीज. क्या ये चीज क्लियर है? Everybody is aligned till now whatever I explained? See, I am going so slow so that you guys can open your mind to learn. I am going so slow so that you can be aligned with me to learn, so that slowly when you will have the harder part of your preparation, harder part of your classes, then definitely you will be quick enough to grasp those things also. So everybody is aligned till now? Sure. So let's go further, let's go ahead. Fine. So what I'm saying is that if you run an algorithm, and if you run an algorithm, that algorithm runs for some time. So we are not calculating the time in terms of wall clock, second, millisecond, nanosecond. We are calculating that how many number of steps or how many number of operations we are performing to run that algorithm. Now in that particular case, what I'm saying is that number of steps also you are not going to give the concrete values or 10,500 steps हमने लिया. No, we will give the rate, the complexity, the number of steps also in terms of rate of growth, so that we can give the any value based on our what, based on our rate of growth, based on our input ka size. Fine. Okay. Now if suppose t of n is a constant value, if you have n equals to 1 input, still the number of steps are 2. If n equals to 2, number of steps are 2 only. If n equals to 5, then 2. If n equals to any value, number of steps performed equal, always same to same, always constant, always, then that is notated as constant complexity. And to denote the constant complexity, we write a notation which is 1. Now you will ask a question, cross question, sir, you told number of steps are 2, but why you are writing 1? Dear, I told it's a notation of having constant number of operations always for any input size. If I have given you an algorithm, you are running that algorithm for any size input, n equals to 1, 2, 3, 500, 5, 600, 800, 8 lakhs, 2 crore, whatever number of inputs you are providing to that algorithm always takes 2 steps only, or let's say 5 steps only. Then how you will define its complexity? The complexity is always constant. It is not at all dependent on the input size. Not at all dependent on the input size. In that particular case, the complexity is constant. Okay, now listen. Constant complexity denoted by 1. 1 का मतलब यहाँ नहीं है, there is no any meaning of 1 that only 1 step is required. No, 1 is denotion of constant complexity. The number of steps can be defined to 5, 2, 6, 10 something, but if it is constant for any n value, then I am going to denote it by 1. Then next complexity you can have is logarithmic. We are talking about only those which are going to be used for our course data structure. Logarithmic complexity. Logarithmic complexity you define by log of n. Then you have complexity linear. How do you define the linear complexity? By n. Then you have logarithmic linear. How do you denote it? N log n. Then you have quadratic, which is n square, and then quadratic, logarithmic, and so on. You have next is cubic, which is n to the power 3. Then ultimately you have a biggest one, exponential complexity, which is 2 power n. Fine. Now listen. If anybody gives you a problem, you will always try to write an algorithm to get the result in constant time. If not, then you will try to write an algorithm which can give the result in just log n time. If not, then at least linear time. If not, then at least n log n time. Means you will try to write the algorithm which takes as minimum as possible time, which is the optimal algorithm for that problem. Right? If you guys are calculating the time complexity after writing an algorithm, you should try to write an algorithm which can give the result in just constant time, if it is possible. If not, then at least in log n. If not, then at least n. If not, then at least n log n, and so on. These are the complexity notations which I have written in the increasing order. I hope you guys are aligned with this particular thing. थैंक यू अमन। सारी पीडीएफ मिल जाएगी आप लोगों को। पीडीएफ के लिए आप लोगों को एक टेलीग्राम चैनल मैं बताऊंगा आफ्टर द क्लास, एट द एंड ऑफ द क्लास। दैट पर्टिकुलर चैनल यू कैन फॉलो सो दैट यू विल बी गेटिंग पीडीएफ इमीडिएटली आफ्टर द क्लास। क्लास के इमीडिएट बाद आई विल be dropping this particular PDF which I am writing on. That particular PDF you'll be getting if you'll be following that particular channel over that channel, Telegram channel. Now listen, what I'm saying is that if you are writing an algorithm which can give the result in constant time, well and good. If not, then log n. If not, then n. If not, then n log n, and so on. That is the increasing order complexity notation. You remember that. Okay? Now listen. One more thing, let's try to understand how exactly we calculate these n log n, constant and linear and so on. So if you write constant here, this we can understand that complexity is not dependent on on input size. Irrespective of input size, you can provide the answer always or result always in constant steps. This notation, all these notations will not only work for runtime complexity but can run for the space complexity also. Space complexity also means, if suppose you are running an algorithm and that algorithm takes the number of spaces, extra number of spaces which are equal to the number of inputs. Suppose I have given you an input n size, n can be anything. To run your algorithm you require n more more spaces. To run the algorithm you require n more spaces. So in that particular case you can say my space complexity is linear for this problem solving. आपको n size का array दिया, n size का input दिया, and you are having n size extra during the algorithm run, n spaces extra during the algorithm run. In that particular case you can say space complexity is linear, just because it is dependent directly on the input size. If input size is 500, you will require 500 spaces. If input size is 1000, you will require 1000 extra spaces. That is the space complexity, in which also you can denote in these notations. All those members who are seeking for operating system classes, I already told you I have started today only absolutely free operating system classes on Unacademy's platform. All those guys who want to learn operating system also, you can come on Unacademy's special classes tomorrow also. Tomorrow is the second class, which is very basic discussion. You can directly jump into second class easily and you can learn. The link of that particular class is already pinned up in your message. So go there and just press a button notify me, so that tomorrow whenever I'll be having classes, which is at 9 a.m, you'll get notified. If you are the first time learner who don't have the account on Unacademy's platform, create your account and unlock your free classes using the code VDEEP10. Free class है, absolutely free. I'll be teaching operating system and I have started it today only. What is the compile time versus runtime difference? CR, compile time means at compile time whatever happens. Runtime means whatever happens on runtime. Very simple. Now look at this. Let's go ahead and let's try to understand exactly how this particular complexity is calculated, number of steps. Okay, fine. Now look at this. There is a particular loop I am writing. So we need to just check out that each statement runs how much time, how many times. So this particular loop statement running from 1 to n, I plus plus means I will be running this statement n plus 1 times. अब आप बोलोगे सर लूप तो n times ही चलेगा. See, 1 condition true, 2 condition 2 true, 3 condition true, I value 4 condition true, up to I value n condition true. Yes, n times you have run. After that, when I value becomes n plus 1, you will check this condition. Yes, so you will run this statement n plus 1 times. N times the condition will be true, last time the condition false, hence you stop the loop execution. So n plus 1 times you will run this particular statement, right? Yes, among those only n times you will be coming inside. Condition is true only n times, so n times you will run this single statement. Total how many number of operations or how many steps you have run? 2n plus 1. 2n plus 1. Now in that particular case, if n value is whatever, the number of steps are in terms of linear. Yes, it's a linear equation. Yes, in that case I can say the complexity is linear. And how do you denote complexity? Linear. Now in linear complexity you can ignore the other values, 2n, n plus 3, n plus 4, 5n or something. Example number 2. Example number 2 is again a very simple one. Let's try to understand each statement runs how much times. This statement, this particular statement will run n plus 1 times. Just now also we have seen. Now for n times you will go inside. For every n time you are going to run this statement n plus 1 times. For I equals to 1, n plus 1 times, I equals to 2, n plus 1 times, I equals to 3, n plus 1 times. So this statement will run how much time? This particular statement will run for n times you will go inside. For every n time you will be running this statement into n plus 1 times. This statement you will run n times, top condition true, n times inner side condition is true. Now listen, what is the total number of steps? Here n square, here n square plus n, here n plus 1. Total how many number of steps? 2n square plus 2n plus 1. Now you can check out that this particular equation is a quadratic equation, hence I can say that the complexity is n square. अब आप बोलोगे सर ये प्लस 2n प्लस 1 इंटू 2 का क्या करेंगे? सी दिस इज जस्ट द नोटेशन डियर. This n square is just a notation that my complexity in terms of quadratic. In terms of what? Quadratic. I am not giving you actual number of steps. I am just giving you that if you increase the number of inputs, n value, in that particular case, my complexity will increase quadratically. That's the only meaning of complexity. So in this case, what will be the complexity? आप बोलोगे सर कॉम्प्लेक्सिटी बहुत कॉम्प्लेक्स नहीं है. I'll tell you one thing. You should be able to solve tough questions if you really want to top in GATE. You should be able to solve tough questions if you really want to top in GATE. You know why? Just because all those members who are learning regularly, normally, not from really great resources or not putting lots of efforts, will be able to solve easy questions, at least from all easy questions, easy topics, easy subjects. But if you are able to solve the tough questions, you will be in the top. You will be in the top. So what I am saying is you should understand, you should learn the complex concepts with more clarity. The concepts, the complex questions you should be able to solve properly in more detail, more crisp manner. Then only you will be in the toppers. That's the simple step. That's the simple tip I just wanted to give you. Fine. So number of steps I have calculated. What is the highest power of n? N square. So of course the complexity should be in n square. I have written it. That is the example number 2. Let's go for example number 3. Example number 3, these two examples I have brought on the same page just because I just wanted to explain you what exactly I am doing. Look at this. I am starting I from 1, going up to n, and after every iteration I am not going with I equals to I plus 1. I am going with I equals to I into 2. Or the reverse. Reverse is starting I from n, going up to 1, and I am dividing by 2, and inside I am doing what? A constant operation. In that case, when I will go from 1 to n, and after every iteration if I am multiplying I by 2, or if I am going from n to 1, and after every iteration I am dividing I by 2, then in that particular case the complexity will become log of n base 2. Why base 2? Just because I am dividing or multiplying by 2. Log of n base 2. I am saying base 2. Yes, log of n base 2. If you are not able to understand exactly, look at this. How did you come to this particular conclusion that the complexity of this algorithm is n? I can directly say that this loop runs n times, around n times, n or something, then it means yes, the complexity is n. Means how many times the loop runs, that is the complexity. Here also, if you have double loop, nested loop, the loop runs n square times, that's why the complexity is n square. So I'll have to check that how many times the loop runs in this case or this case. Let's assume loop runs x times. You can easily check out if loop runs x times. For I equals to 1 you will run the loop. Yes. For I equals to 2 you will run the loop. Then I equals to 4. Then I equals to 8 you will run the loop. I equals to 16 you will run the loop, and you will keep going. If suppose n equals to 32, how many times you are running the loop? How many times you are running the loop? I equals to 1, you are running the loop. I equals to 2, running the loop. I equals to 4, into 2, 8, yes, into 2, 16, yes. After that, into 2, 32, no, you will not run the loop. How many times you have run the loop? 5 times. So can I say you will run the loop up till 2 power x is less than n value? Understanding what am I saying? If you are saying that key loop runs x times, then in that case the final value n should be greater than 2 power x, to multiply by 2, multiply by 2, multiply by 2. And from here, if you get the value of x, you will get log of n base 2. And that is what? As many as times the loop runs, that is the complexity. This one. So both, if you will ever encounter such kind of situation when you have starting from 1 to n, every time after every iteration you are multiplying I equal to I into 2, I into 2, or reverse, if you are starting with n going towards 1, and if you are dividing it by 2 by 2 by 2, you will get complexity log of n base 2. All these I am explaining why, just because all these will require in my data structure course. This is the data structure course dear, but ये course में required है, इसलिए पढ़ा रहा हूँ. वरना फिर मैंने बोल दिया कि अच्छा इस पर्टिकुलर एल्गोरिथम ये मैंने लिखा, आई एम सेइंग दैट ओके आई एम अप्लाइंग दिस ऑपरेशन ऑन दिस पर्टिकुलर लिंक लिस्ट, दिस डेटा स्ट्रक्चर, एंड दिस विल टेक दिस मच टाइम. आप बोलोगे सर हमको तो पता ही नहीं है, ऐसा कैसे हो गया सर? हाउ कैन यू से लॉग इन, हाउ कैन यू सेंड एन? तो फिर मैं अब बैठा बैठा देखूंगा अब कैसे समझाया जाए तुमको. In that case, I can definitely make my words clear that I explained in first two lectures that how exactly the algorithm works. Sheikh Samruddin, yes, you can follow this lecture series. You will certainly enjoy this for your placements also. Now look at this. Look at this. You understood all these problems, everything fine. Now let's talk about these two forms. What is big O notation, omega notation, and theta notation? So many students get confused about this. So many students get confused about this. Ki sir, what is big O? Why omega is used, when the theta is used, and so on. Now, there are two things. First is asymptotic notation. Second thing is the cases, best case and worst case. I will talk about both the things separately. Let me talk about this first. Okay, चलो। राहुल राज का क्वेश्चन है, सर आप एल्गो भी करवाओगे? राहुल, पहले डेटा स्ट्रक्चर तो पढ़ ले बाबा, पहले डेटा स्ट्रक्चर पढ़ लेते हैं, इसको समझ लेते हैं, फिर एल्गो का भी कुछ जुगाड़ करेंगे। ये तो पढ़ो, इतना फ्यूचर का क्यों देखना है, पहले प्रेजेंट में जियो यार, ठीक है। बिग ओ नोटेशन, व्हाट बिग ओ नोटेशन गिव्स यू? इट gives what? Tightest upper bound. You will not understand the statement. You will not understand it as it is. I'll tell you what exactly the meaning of it. First, I will take a very simple example from your real life. I'll take very simple example from your real life. And that example is what? Let me check. Let me tell you. Suppose you are sitting at your home and studying. See, this is very dangerous work. You will not have to repeat at your home. पढ़ने का काम बहुत dangerous होता है, करने का नहीं घर में, just assume करने का. You are sitting at home, studying, jokes apart, and suppose your father comes to you. He is giving you some money, let's say 2000 rupees, and giving you some list of items to purchase from market. कि ये सारे items लेके आ जाओ. Now see, your father has given you 2000 rupees by some calculations. What is the calculation? The calculation is, if you will go to the market, any shop, any place, if you will go suppose to the closest place, which is a supermarket, and if you will purchase all these items, you will have to spend 2000 rupees, but not more than that. But if you will go to some other shop, it might possible that you can get the items in just 1200 rupees. Some other shop you can get the items in just 1500 rupees. Of course, थोड़ा दूर जाके वो लाना पसंद करोगे क्योंकि बचा हुआ पैसा जेब में. पापा पूछेंगे बचे हुए पैसे, आप बोलोगे कौन से पैसे, कैसे पैसे, वो मेरे कमीशन के, राइट? नाउ लुक एट व्हाट एम आई सेइंग इज दैट if your father has given you 2000 rupees and you have been asked to purchase some items, you are going to some shop, it is possible, let's assume it is possible that you can purchase the items in 2000 rupees from some shop, but at some shop you can get the items in just 1500 rupees. In some shops you can get the items in just 1200 rupees. In some shops you can get the item in just 1000 rupees. But in any of the shop you will not spend more than 2000 rupees. So that 2000 rupees is the upper bound. That 2000 rupees is the upper bound, that in any case you will not require more than 2000 rupees. So let's now map this particular thing on our asymptotic notation. Suppose I have given you an algorithm. I have given you some input. You are writing an algorithm and you are saying that, sir, this algorithm is having its complexity big O of n. Let's assume you have given big O of something, big O of n or big O of log n or big O of n square or something. Now what happens? In that particular case, you can say, sir, when we will run the algorithm, maximum number of operations or maximum number of steps are required equal to n. But I will ask a cross question. Is it possible that your algorithm can stop with less than n number of steps? You will say, ha, yes, sir. For some input, it might possible that my algorithm can stop with just n by 2 steps. or my algorithm can stop with just 1 step, 2 step, 5 step, 10 steps. But maximum how many operations or steps are required to be performed is n. That is why you will write outside big O of n. ज्यादा से ज्यादा n स्टेप्स लगेंगी, उससे कम में भी काम चल सकता है, हो सकता है उससे कम में भी आंसर आ जाए, बट इससे ज्यादा नहीं लगेगा. Hope you guys are understanding that. So what is the meaning of big O notation? The meaning of big O notation is, if you say big O of this is your complexity, then that this is actually maximum number of operations required to run the algorithm. Might possible less than that also, fine, to work with the algorithm. I'll give you an example. Suppose I have asked you that you will have to search your friend in entire college. You don't have mobile phone. Your friend also is not having any mobile phone. You will have to search your friend. And let's suppose you have total 10 places, or let's reduce it. You have total 5 places where you can find your friend in your college. So what are the 5 places? The first place is canteen, of course. The second place is, let's say, the college lobby, the entrance lobby. The third place is classroom. Fourth place is, let's say, some library. And fifth place is, let's say, some bus stand where you take your, or let's say, parking. So what you will do? You will first go to canteen. If you find your friend over there, will you keep searching into other areas also? Will you keep searching in other areas also? Yes or no? Batao. Tell me. No. So can I say you stopped your algorithm in just one step? Yes. But is it possible that always you will get your friend in canteen only? No. If your friend is not present in canteen, you will go to college lobby. If not present in there, you will check out in classroom. If not present there, you will check out in library. If not present in there, in parking. If not present in there, बोलोगे मर गया, पता नहीं कहीं गया है तो छोड़ो इसको. Right? घर गया होगा, I don't know. So how many maximum places you will search? 5. But is it possible that you can find your friend within less than 5 steps also? Yes. That is why you will say, I will have my complexity is big O of 5 or big O of n. I guess you understood with 2 different examples, and that is what the big O notation. So big O notation says what? Tightest upper bound, इससे ज़्यादा steps नहीं लगेंगी. More than these steps will not be required. Less than these possible? Yes, possible. Let's talk about omega notation now. It gives tightest lower bound. Did you understand big O notation, everybody? Yes or no? Jaldi se type karo in the message box so that I can understand and I can go further and I can explain you omega. So what is the meaning of omega? Omega gives you tightest lower bound. Now listen, I am going back to that same example of father and the purchase of items. So your father has given you 2000 rupees first and given you a list of items. You can purchase the items in 2000, less than 2000 also. Now let's say you come back home. Your elder brother comes. बोलोगे सर बड़ा भाई नहीं है. अरे अज्यूम करो यार, assumption है, कहानियां हैं, हो सकता है बड़ा भाई हो. Now look at this. Your elder brother comes. Your elder brother comes and that fellow says that you will have to purchase some items from the market. I am giving you 500 rupees. Now the thing is, your elder brother of course is not earning much, so he will give you very tight amount. If you will go to a very specific shop in the city, you can get it in 500 rupees, otherwise not. All the items you can purchase only when you will go to the old market, very specific shop, otherwise not. Otherwise you will have to you will have to search on more steps, or you will have to spend more money. So tightest lower bound is given by omega, means if suppose I have written that for some algorithm the tightest lower bound is omega n, what does it mean? It means that minimum n number of steps required to perform that operation. More than n can be required, yes, can be required. Less than n पॉसिबल ही नहीं है. n से कम में काम नहीं चलेगा. Less than n, no. More than n it is possible. That is omega, right? So might possible you can get your brother's list of items in 500 rupees, maybe more than that, but less than 500 rupees you will not get anywhere in the entire market, entire city. That is tightest lower bound. Fine. So it might possible that for some algorithm I am having tightest lower bound is equal to log n and tightest upper bound is equal to n. Possible? Yes, of course possible. For some algorithm tightest lower bound is log n, tightest upper bound is n. कम से कम log n steps, maximum n steps are required. Minimum log n, maximum n steps required. Possible for single algorithm? Yes, possible. Now let's talk about theta bound. It gives you average bound. In my language, for understanding, it gives you exact bound. See, for certain algorithm, let's say one algorithm takes maximum n number of steps and minimum also n number of steps. Tightest lower bound is also n, tightest upper bound is also n. I can say exactly n steps are required. Yes, that you can write as theta of n. That you can write as theta of n. Now, how exactly we can understand it? Suppose you are coming back home. Now your mother comes to you. She is giving you 542 rupees. Go to the market, take these items. Now your mother is very, very calculative. Whichever shop you go, wherever you go, you will get all the items in 542 rupees. Nothing more than that, nothing less than that. In that case, you will have to give theta bound. That if any algorithm is taking exactly those many number of steps, not less than that, not more than that, that is exact bound. That is exact bound, average bound or theta bound. Now there is a difference. Now there is a difference between two things which are best and worst cases. What is the meaning of best case? The best case is that input. Best case is that input for which your algorithm takes minimum time. And worst case is that input for which your algorithm takes maximum time. Minimum time can also be denoted in any of these three asymptotic notations. Yes. Maximum time also you can denote in any of these three notations. Yes. Right? So best case is that input for which your same algorithm takes minimum time. Worst case means that input for which your algorithm takes maximum time. That are the cases, and case is nothing but type of input. Type of input for which the same algorithm can take different time. For some algorithm, it may work that we have two cases, best case and worst case. For some algorithm, we don't have any particular type of input. All the inputs will take equal time.